millions of homes and factories. Workers and their families lived in Pripyat, a model Soviet city with modern amenities, schools, and a palpable sense of optimism. The heart of the plant was 4 RBMK-1000 reactors. The RBMK was a uniquely Soviet design. It used graphite blocks to moderate the chain reaction and water to cool the fuel rods. That allowed online refueling and even the production of plutonium. But it hid a deadly secret, a critical design flaw called the positive void coefficient. At low power, loss of cooling water could make the reaction accelerate violently, not slow. That counterintuitive, catastrophic trait was known to only a handful of top scientists. On the night of April 25, 1986, the day shift prepared a long-delayed safety test at Reactor 4. The experiment aimed to see if slowing turbines could supply residual power to run the emergency cooling pumps for the crucial 60 seconds until backup diesel generators started. It was meant to bridge a known safety gap, but the procedure was poorly planned, and the crew were dangerously unfamiliar with the reactor's behavior under these conditions. The test was handed over to an unprepared night shift. Delays and operational missteps began to pile up. The regional grid controller refused to allow the scheduled shutdown, forcing operators to hold the reactor at a low, unstable power level for hours. When permission finally came, they struggled to raise power to the required level. Under haste and pressure from superiors, they overrode automatic safety systems and manually withdrew nearly all control rods, effectively removing the brakes from a machine they were about to stress test. The flawed giant was now primed for disaster. With the reactor in an exceptionally volatile state, the operators initiated the final stage of the test at 1:23 a.m. They shut off the steam to the turbine, simulating a power failure. Cooling water flow through the core decreased. In a normal reactor, this would slow the reaction. But in the RBMK-1000, its positive void coefficient dominated at low power. The opposite happened. Pockets of steam, voids, formed in the cooling channels. These voids allowed more neutrons to strike the uranium fuel. The fission rate and power surged uncontrollably. Operators watched in horror. Console dials spun wildly, showing a terrifying power spike. Shift supervisor Alexander Akimov made a desperate attempt to shut the reactor down. At 1:23:40 a.m., he pressed the AZ-5 button. The AZ-5 was the emergency shutdown to plunge all control rods and stop the chain reaction.